scientists discover that epigenetic memories are passed down for 14 generations. The most important set of genetic instructions we all get comes from our DNA passed down through generations, but the environment we live in can make genetic changes too. Researchers have discovered now that these kinds of environmental genetic changes can be passed down for a whopping 14 generations in an animal, the largest span ever observed in a creature, in this case being a dynasty of C. elegans nematodes, or roundworms, as we can see here in the image. To study how long the environment can leave a mark on genetic expression, a team led by scientists from European Molecular Biology Organism EMBO in Spain took genetically engineered nematode worms that carry a transgene for fluorescent protein, then activated this gene, made the worms glow under ultraviolet light. And we see them glowing. Now, then they switched things up for the nematodes by changing the temperature of their containers. When the team kept nematodes at 20 degrees Celsius, at 68 degrees Fahrenheit, they measured low activity of the transgene, which meant the worms hardly glowed at all. But by moving the worms to a warmer climate of 25 degrees Celsius at 77 degrees Fahrenheit, they suddenly lit up like little wormy Christmas trees, which meant the fluorescent gene had become much more active. Their tropical vacation did not last long, however. The worms were moved back to cooler temperatures to see what would happen to the activity of the fluorescent gene. Surprisingly, they continued to glow brightly, suggesting they were training an environmental memory of the warmer climate, and that the transgene was still highly active. And furthermore, that memory was passed on to their offspring for 7 brightly glowing generations, none of whom had experienced the warmer temperatures. The baby worms inherited this epigenetic change through both eggs and sperm. The team pushed the results even further when they kept 5 generations of nematodes at 25 degrees Celsius, that's 77 degrees Fahrenheit, and then banished their offspring to colder temperatures. The worms continued to have higher transgene activity for an unprecedented 14 generations. That's the longest scientists have ever observed the passing down of an environmentally induced genetic change. Usually environmental changes to genetic expression only last a few generations. We don't know exactly why this happens, but it might be a form of biological forward planning, says one of the team, Adam Closen from EMBO, and Pompeu Fabra, University of Spain. Worms are very short-lived, so perhaps they are transmitting memories of past conditions to help their descendants predict what their environment might be like in the future, adds co-researcher Tanya Vavori from the Josep Carreras Leukemia Research Institute in Spain. There's a reason why scientists turn to C. elegans nematodes as a model organism. After all, those 14 generations would only take roughly 50 days to develop, but can still give us important clues on how environmental genetic change is passed down to other animals, including humans. There are many examples of this phenomenon in worms and mice, but the study of environmental epigenetic inheritance in humans is a hotly debated topic, and there's still a lot we don't know. Inherited effects in humans are difficult to measure due to the long generation times and difficulty with accurate record keeping, states one recent review of epigenetic inheritance, but some research suggests that events in our lives can indeed affect the development of our children and perhaps even grandchildren, all without changing the DNA. For example, studies have shown that both the children and grandchildren of women who survived the Dutch famine of 1944-45 were found to have increased glucose intolerance in adulthood. Other researchers have found that the descendants of Holocaust survivors have lower levels of the hormone cortisol, which helps your body bounce back after trauma. The latest study on nematodes is an important step towards understanding more about our own epigenetic inheritance, especially because it serves as a remarkable demonstration of how long-lasting these intergenerational effects may be. And the findings were published in Science magazine. This is by Sinj Dean Science Alert, and it's on Bended Reality. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.